very quickly in 15-20 minutes, we are going to see LMTD and effectiveness method. Okay, although in GATE it is not very, like it will not be very helpful, but at least you will get a quick idea of how and what must be given to you, what parameters you are going to look into the question, and what formulas you can use, what formulas you can use to solve the question. Okay, so very quick. Now, you see LMTD. First method is LMTD. Whatever we have, LMTD or log mean temperature difference. Okay, this is what we are going to use. Now, when do we use LMTD? Okay, now LMTD is actually used when at least you have given three temperatures. If in the question they are giving you two temperatures, either they will in LMTD method, either they will give you three temperatures or all four temperatures. What are the four temperatures? Can you tell me? What are the four temperatures I am talking about? Yes, very nice. Hot fluid temperature inlet exit and cold fluid temperature inlet exit. Okay. So if they are giving you less than this, if they are giving you two temperatures, then you cannot use LMTD. Okay, LMTD is not a very generalized method. Okay. So, and usually it is used to calculate area. It is used to calculate area. Okay, now let us see what we need to calculate. In the design of any heat exchanger, it is required to obtain the area of heat exchanger, area of heat transfer needed for a given heat transfer rate. Now, what do we need to calculate here? Diameter of tubes. These four parameters we need to calculate, or one or two parameters out of these. So D is diameter of each tube, length of heat exchanger, number of tubes per pass, and number of passes. We are going to see number of tubes and number of passes in a minute. But let us see usually what are the things that you are going to look into the question. Not just LMTT method, but in every question, what are the parameters that you are going to look? Okay, okay. So first thing, usually in question you will see what rate of flow rate. Okay, mass flow rate of hot fluid and mass flow rate of cold fluid. These are the two things that you will see. Then specific heat of both of them, cold and hot fluid, cold and hot fluid. Then sometimes they will give overall heat transfer coefficient. Why? Because you know that if they will ask you heat transfer, then you will need this UA delta TM. So U may be given to you in question, and at least three temperature, or sometimes four temperatures, but at least three temperatures, not less than three. Okay, chalo. Now let us talk about these two things. So these are the tubes actually. These are the tubes. So it has four tubes. Number of tubes, that means four tubes. Okay. What do you mean by tube? Once it is entered, once the where the fluid is entering and the fluid is exiting. So the total path in which the fluid is flowing is one tube. Okay. So fluid will enter from here and exit here. So it is one tube. Here, fluid is entering from here and exiting from here. So it is all one tube. So it has three tubes. Okay. But passes, what do you mean by passes? If the tube is, it is molded or it is rounded or it is turned to decrease the length of the heat exchanger. Okay. So basically we have three tubes, but this is basically it is the same fluid is taking two rounds. The same fluid is taking two rounds into the heat exchanger. Okay. So here we have pass one. Number of passes is one. Here we have two passes. If we move it like this itself, the tube, then it will be three passes. Okay. So passes are provided only when the heat exchanger area required is large. That means a very large heat exchanger area is required, but the length of the heat exchanger is limited. You cannot make like 100-meter heat exchanger. It is limited. So what will you do? You will take turns. You will have more number of passes. So the same tube will be circulating. Okay, chalo. For example, steam condenser of a thermal power plant or chemical unit. By providing passes, we can reduce length of the heat exchanger. Length of the heat exchanger. Okay, chalo. Now, what will you do? First of all, now what do you need to find out? You need to find out area. Area means diameter and length. Area of heat exchanger. So basically, dia and length. These things you need to find out. So first of all, they have given you, let's say, three temperatures. They have given you three temperatures. So what will you do? What will you do? By, you know this, right? You know this diagram. For example, it's a parallel flow. It's a parallel flow. So TH inlet, TH exit, and this is TC inlet, TC exit. So you know, look, this is already given to you in question. This is already given to you, and three temperatures are given to you. So you can use this heat transfer equation and find out the fourth temperature. Okay, so you will calculate the fourth unknown temperature. The fourth, I am assuming that three temperatures are given. Yes, I am assuming that three temperatures are given. So you will find out fourth temperature using this equation. Using this equation. Then you will draw this temperature profile that I have drawn here and find out LMTD by delta T1 minus delta T2 upon ln delta T1 by delta T2. Okay, this is what you are going to find out next time. This is delta T1. This is delta T2. Okay. Now, step third. Then, then you will find out the heat transfer rate. Heat transfer rate of hot and cold fluid. Hot and cold fluid. So you can take either one of them. You can take either this or this, and you will find out the heat transfer rate. The heat transfer rate either by hot fluid or by cold fluid. Okay, so once you have calculated this, then you can apply this in this equation and find out area. Okay, so area you can find out by this equation. Okay, now area is also pi dl or 2 pi rl, whatever you want. So it is either 2 pi rl or pi dl. Okay, and the total area, this is the area of one tube, and if it is one pass, but to calculate the total area you have to multiply it by number of passes and number of tubes. So NP, this is your area. Now there are two unknowns in this. D is unknown and L is unknown. Okay, but you remember that in the question they have given you these two parameters. Okay, so you can use any one of them and you can take mass flow rate is equals to rho v rho av rho av. Okay, so rho, area, and velocity, and this is the number of tubes. Okay, so diameter you can find out from here, and then only length is remaining that you can find out from this equation. Clear? Is it clear? Usually in IES conventional exam, ESC conventional exam, that ask to design the whole thing. So you will need to go step by step. But here in gate questions, you will use any one or two steps and find out the unknown parameter. Okay. You will just need one or two steps, not all of them. Chalo, chalo. Now this is your LMTD method. Next is effectiveness NTU method. Effectiveness NTU method. Now you will only use this method when only two temperatures are given in designing. In designing, when two temperatures are given. Okay, then you can, if two temperatures are given, then LMTD method reaches its limitation. Reaches its limitation means reaches its limitation, it simply means you cannot use this limitation. You will not be able to solve using LMTD method. Okay, chalo. Now in this, what will be the given data? By mass flow rate of hot and cold fluid, and this. Also, this will be given to you. Two inlet temperatures are given, and area of heat exchanger in this question will be given to you. You will need to find these two temperatures. These two temperatures. Okay, chalo. Let us see the steps. Step one. Step one. Look, they have already given you these two parameters. So you can find out MCP max. It could be anyone. MCP minimum. But it could be for hot fluid or cold fluid, any one of fluid, hot or cold fluid. Okay. And using this, you can calculate your capacity rate. Which one is smaller, you will keep in the numerator, and the bigger one you will, or the maximum one you will put in the denominator. Okay. Once you have calculated this, you can also calculate NTU. By this is given to you, this is given to you, and you have also calculated the small one, minimum one. So using that, it is what? UA m dot cp minimum. You can calculate this. Now what do I know? That effectiveness is a function of NTU and capacity ratio. So whatever is given to you in question, for example, condenser is given, evaporator is given, counterflow heat exchanger is given, parallel flow heat exchanger is given, you are going to use that equation that we discussed and calculate effectiveness. Okay, is it clear? But it is not effectiveness that you want. What do you want? You want temperatures. So bhaiya, effectiveness can also be written as what? Effectiveness can also be written as Q dot actual upon Q dot maximum. And maximum, we all know that it is M dot Cp minimum and THI TCI. So it is fixed. It is fixed. Now, based upon, so look, denominator is fixed here. Now, if you need to find out either any of these temperatures, so you can take this, or any one of these temperatures, so you can take hot fluid in the numerator. So you will calculate only one temperature from here. Only one temperature can be calculated. Temperature can be calculated from this equation. Once you have calculated one, so now you have total how many temperatures? Now, once you have calculated one temperature from here, how many total temperatures? You have three. And then you will again use this formula to calculate the fourth temperature. Clear? Chalo. So again, in gate, you will not need all the steps. You will need either one or two steps in either of the methods. So I am not saying it is completely wasteful, I mean waste of our time to see the designing. Okay, if ESC is there, then you have to write step by step all the process, all the steps. Okay, one by one. But in your gate question, only one or two steps will be more than enough to solve the question. Chalo, very nice. Let's start the question, right? Let us start the question. Yes or no? Or any doubt till now? Any doubt? Yes or no? Okay, chalo. Clear? Chalo. Now, what is the question saying? Now you need to pick out the words that you need. Look, GATE 2010 2-mark question. An industrial gas enters a parallel flow. So this is very important information. This is my C. Now I don't know it is hot fluid or cold fluid. I'll see it in some time. Okay. Parallel flow heat exchanger. As soon as you see parallel flow, draw the temperature profile of your parallel flow. If you don't know which heat exchanger is it? You can't draw, but you know it is parallel flow. So of course the temperature profile will be like this. Okay, this is 1, this is 2. Okay, now so it is entering at 250 with a flow rate of 2 kg per second. Okay, so we have C is equals to 1 kg 1 kilojoule per kg Kelvin, and mass flow rate 2 kg per second. I still don't know it is hot fluid or cold fluid. But the next line, to heat a water stream, that means this gas is heating a water stream. So that means this gas is my hot fluid. This gas is my hot fluid. So this is my hot fluid. So it has m dot h and ch. Okay, and it is entering at 250 degrees Celsius. This is my thi. I am writing all the notations in this question. Later on, I will not write all the notations. ठीक है? चलो. And with a flow rate of, let me write flow rate as well here. So mass flow rate of hot fluid is 2 kg per second, and Cp of hot fluid is 1 kilojoule per kg Kelvin. Okay, now it is used to heat a water stream. Now water stream with C 4 kilojoule. So C of Cp of cold fluid is 4 kilojoule per kg Kelvin, enters the heat exchanger at 50 degrees Celsius. So it is entering, where it will enter? Here it will enter. Tci is equals to 50 degrees Celsius with a flow rate of 1 kg per second. Mass flow rate of cold fluid is 1 kg per second. Effectiveness is also given. Effectiveness is 0.75. Effectiveness is 0.75. The gas stream exit temperature will be, gas stream का exit temperature, तो यानी कि the hot fluid exit temperature, I need to find out TH exit. This I need to find out, but I don't even know this as well. I don't know if I'll require it or not, but I need to find out THE. I need to find out THE. ठीक है, चलो. Let us see this. Let us see. So I need this. I need this. Okay, let me try to explain something here. Okay, so how do I find it out? Now, look, I know only two. I know only two temperatures. So I cannot use my this equation. I cannot use this equation. I cannot use this equation because for this I at least need three to find out fourth. Okay, so I at least need three. But effectiveness is given here. Effectiveness is, so what is effectiveness? Effectiveness, let us see. Effectiveness is equals to Q dot actual upon Q dot maximum. Now before I write Q dot maximum, जो होता है M dot Cp minimum THI TCI. Before I write this, I need to find out which one is minimum. Okay, so let us see. M dot Cp of hot fluid is equals to 2 into 1. Okay, so it is kg per second. It is kilo joule Kelvin second, right? Kilojoule Kelvin second. हाँ, M dot Cp cold क्या है? It is 4 into 1, which is 4 kilojoule per Kelvin. So this is my minimum. This is my minimum. Okay. Yes, we will start with effectiveness. Yes, right. Okay. Sean, yes, Sahil, that is correct. That is correct. Okay, we will also go fast, but let me at least explain all the notations. ठीक है, चलो. So I know this one is minimum. I know this one is minimum. So tell me which heat actual Q dot actual I will take in the numerator. Which one I should take? Cold fluid or hot fluid? Which one should I take in the numerator? Hot or cold? Hot. Yes, very nice. because I can cancel MCP minimum. So I can write M dot H CPH TH I minus TH exit. Now I can cancel these two because MCP minimum is basically MCPH. So now what is effectiveness? Effectiveness is equals to THI minus TH exit upon THI minus TCI. Now I know effectiveness is given in question 0.75. THI and TCI both are given. THI is this, TCI is this, 250 and 50. Okay, very nice. This is 250. This is THE. This is again 250 and this is 50. Of course, you can calculate 250 minus THE is equals to 200 into 0.75. And THE, you will get 100 degrees Celsius. Simple, isn't it? Isn't it simple? So it is 100 degree Celsius. Okay. And it is a great question. I am not just making questions simple for you. These type of questions are asked in exam anyway. Okay, chalo. Let us move on to the next question. Now, point सबसे first, water at 80 degrees Celsius enters a counterflow heat exchanger. As soon as you see counterflow, draw counterflow. Please do not try to solve the question without drawing the temperature profile. Mostly you will confuse between THI, THE, delta TM. All these things will be very confusing. Okay, so if you are in the habit of this, it will not take more than 10 seconds. Counterflow is like this. Okay, chalo. 80 degrees Celsius, it is entering a counterflow heat exchanger with a mass flow rate of this. Now, air enters at 30. If air is entering at 30, that means air is the cold fluid, water is the hot fluid. Okay? Chalo. This is 80 degrees Celsius is given and 0.5 kg per second is given and C is equals to 4.18 kilojoule per kg Kelvin in given. What else is given? 30 degrees Celsius is given entering and this is 2.09 and 1. 2.09 kg per second and 1 kilojoule per kg Kelvin. Okay. Effectiveness is also given. Effectiveness is 0.8. Find out LMTD. LMTD I need to find out. Okay. Let us start with LMTD. LMTD, what do I require LMTD for? By delta T1, delta T2, ln delta T1, delta T2, right? Now, what is delta T1? This is first, this is second. So this is delta T1, delta T2. Now I can only find out delta LMTD once I know all the four temperatures. It is very important, all the four temperatures. Okay, chalo. So how do you calculate delta TM? You are answering A. Why A?
Hello, sir.
Yeah, one second, one second. Yeah, Raj, I do not have laptop. Yes, tell me.
Sir, because they have given the effectiveness, right?
Yes.
So I've used the effectiveness formula here.
Mm-hmm.
And with
No,
the
you
help
can
of
use,
effect,
yes, yes. You can use effectiveness. Of course, you can use effectiveness. But are you not observing something here? Are you not
sir, like,
observing?
sir, heat capacities are same for counterflow.
Yes,
And
yes. And it is
LMTD like
count.
is equal to, yes, sir.
So if it is, if two conditions, what? m dot cpc is equals to m dot cph. First is this, and second is counter flow. If these conditions are satisfied, then what does it mean? What does it mean? It is a, first of all, it is a balanced. If this condition is satisfied, it means it is a balanced heat exchanger. And when you calculate, you can use effectiveness, you can calculate these two temperatures also. This is tc exit, this is th exit. You can calculate that, no problem. But there is no need to calculate. Why? Even if you calculate, delta T1 will be equal to delta T2. How much are you getting? Are you getting TCE? TCE are you getting? Hmm? Hello? Okay. Now you are not saying some. Okay. Chalo.
Hello, sir.
So, tell me.
Sir, first of what I have done with the help of the effectiveness formula, I have calculated THO. So, sir, by mistake, I have given the answer as THO, that is 40 degrees centigrade.
Yeah, but they are not asking THO.
Yes,
Achha, you
sir.
have given
That's my
THO as
mistake,
answer.
sir.
No, no, no,
Yes, sir.
no. Do not do that much of hurry. Okay, please. They are asking
Right, sir. Right, sir.
LMTD. Okay,
Yes, sir. I
so
understood, sir.
you, if they have given effectiveness to confuse you. Look, you use effectiveness. Of course, you can calculate THE. Okay, then you can calculate by using our equation. You can calculate TCE as well. No problem with that. But once you do that, you will anyway find that delta T1 is equals to delta T2. Okay, and we know if delta T1 is equals to delta T2, then your log mean temperature difference is 0 by 0, which is undefined.
In
And
that case,
then
we can consider
only,
delta T1, delta Tm equals to
yes,
delta T1 or
in
equals to delta
any
T2.
one of them. And so you don't need to do all that. As soon as you, when you are writing the values, no, m dot cp,
Yes, sir.
if you keep a close watch on these numbers, you will anyway, you will get an idea कि यार ये तो like it is coming equal. It like it, अगर आपको you have a little bit of doubt कि it is equal, just calculate it quickly कि अच्छा it is equal. Then you just apply this formula, and this is equals to 10 degree Celsius.
Yes, sir.
Okay,
10 degrees
so
centigrade. Yeah.
but in order to calculate that, what do you need? You need at least one temperature. You need at least one temperature, right?
Right, sir.
So that you can calculate using effectiveness, which is,
Yes.
you can take hot or cold fluid, anything, no problem, because minimum is same for both of them. Okay, MCP minimum is same, so you can take, let's
Yes.
say, THI minus THE upon THI minus TCI. So from here you can calculate THE, which I think you have told me it is 40 degrees Celsius. You write 40 here, and your delta T2 comes to be 10 degrees, and delta T1 will come at 10 only, but you don't need to calculate that. Okay. Yes. Sean, is it clear? Sahil, is it clear? Shruti has also joined. Is it clear, Shruti? I think you are late today, but we are only practicing questions, so you are all aware of these formulas, I guess. Okay. So, like what the special cases that we have discussed, no, it is very important. If you are revising all the formula at least once, then revise those special cases at least twice. So as soon as you see any of the special cases, then your simplification actually reduces to half of the total calculation. Okay. So our answer is 10 degrees Celsius. Next question. 10 is my answer. Chalo. In a this is 2014 1 mark question. In a heat exchanger, it is observed that delta T1 is equals to delta T2, where delta T1 is the temperature difference between the two single phase fluid streams at one end. We all know this diagram. We all know this diagram. It is giving me THI, TC, THE, T, and 1 second. It has given me counterflow. It has given me counterflow. Okay. TCI, TCE, and it is telling me that delta T1 is equals to delta T2. Okay, so it is at one end and delta T is the temperature difference at the other end. The heat exchanger is, what is the heat exchanger? It is a condenser, it is an evaporator, it is a counterflow heat exchanger, it is a parallel flow heat exchanger. What is the answer? Come on. There is no other information here. Yes, C is the answer. Of course, C is the answer. Look, in parallel flow, you can never get this condition. Parallel flow will be like this. So you will not be able to get this condition in parallel flow ever. Okay, it can only happen in counterflow. It can only happen in counterflow. Clear? Chalo, let us move on. Should we move on? Or do you have any doubt? Chalo, chalo, ठीक है, let us move on. Now, next question. Get 2014 2-mark question. Chalo. Now, what do we have? A concentric counterflow. Very important word. सबसे पहले, first of all, you need to mark which type of heat exchanger it is. Counterflow heat exchanger. Water flows through the inner tube at 25 degrees Celsius and leaves at this. And as soon as you know it is counterflow, it is a good idea to draw this diagram. Temperature profiles. Okay. Now, this is hot. This is cold. Now, I don't know which one is hot, which one is cold. Okay, so I need to read the question further. The engine oil enters at 100 degrees Celsius and flows in the annular flow passage. The exit temperature of the engine oil is 50. So now I know, look, water is entering at 25 degrees Celsius, oil is entering at 100 degree. So which one is the hot fluid? Which one is the hot fluid? Yes, oil. So oil is entering at 100 degrees Celsius and water is entering at 25. Very important to mark these temperatures in the temperature profile. Otherwise, a lot, because you know you have so many temperatures. But you have THI, you have THE, you have TCI, you have TCE, you have delta TM, you have delta T1, delta T2, so many for temperatures. So it is always a good idea to draw the diagram, draw the temperature profile and mark the temperature there. Okay, so your confusion will not be there. It is coming out at 42 degrees Celsius. Now, exit temperature of engine is 50 degrees Celsius. Okay. Now mass flow rate is also given by mass flow rate of water and oil. So oil mass flow rate of oil is equals to, or hot fluid. Let us say hot fluid. Once I have identified hot fluid, let me write hot fluid. Mass flow rate of hot fluid is 1 kg per second. Mass flow rate of cold fluid is 1.5 kg per second. Specific heat of water and oil is also given. So specific heat of what C, just C, not dot. CPW is 4178 and C P of oil or hot fluid is 2130. Effectiveness I need to find out. Effectiveness I need to find out. So if I need to find out effectiveness, what do I know? I know that Q dot actual upon Q dot maximum. 0.667 is the correct answer. Very nice. Very nice. Okay. Now Q dot maximum, I always know, सबसे पहले you need to calculate M dot Cp minimum and THI minus TCI. So I need to find out which one is minimum. Which one is minimum? So just by looking at them, I can say that the hot fluid is minimum. Just by looking. If you can't see that just by looking, then calculate it first. Okay. But just by looking, I can say that hot fluid has minimum heat capacity. So I will use what? M dot H CPH THI THE upon M dot CP minimum THI TCI. Okay, this will get cancelled. Effectiveness will be THI. THI is 100, THE is 50, and this is 100 minus 25. And you have already calculated this. It is 0.667. Very nice. Clear? Chalo, everyone has already answered. Shruti, is it clear? You have not answered. I have told you, no, that day, didn't I tell you that you tell me one thing, that if this is a body, okay, this is a fluid or water, whatever it is, okay, and I am saying I want maximum heat transfer, okay. Now you tell me the heat storage capacity of this fluid should be high or low if I want maximum heat transfer from this fluid. Then heat storage capacity should be high or low? Low, of course, low. Otherwise, heat transfer will not be, it will not be, you cannot maximize the heat transfer. Most of the heat is actually stored in the body. Temperature is not changing. Okay, so heat storage capacity you want minimum. That is why for Qmax we are taking minimum. Clear? Chalo. Chalo. Let us move on to the next question. Very nice. This is what we have already done. Chalo. Now again, next question. We have a double pipe counterflow. Very important information. Parallel and counterflow. Counterflow. Draw counterflow. Okay. Heat transfer, counterflow heat exchanger transfers heat between two water stream. You see, hot and cold fluid, both are water. Now, tube side water is 19 liter per second is heated from 10 to 30. That means it is the cold fluid. It is heated from 10 degrees Celsius to 38 degrees Celsius. And its volume flow rate is 19 liters per second. Okay. Now shell side water is 25 liters. Now I know, of course, it is hot fluid. Okay. So it is volume flow rate is equals to 25 liters per second is entering at 46 degrees Celsius. Take density of water as this, specific heat at this. LMTD I need to find out. LMTD I need to find out. So before I find LMTD, I need to find the fourth temperature. I need to find TH exit. Then only I will be able to find out. Then only I will be able to find out delta T1 and delta T2, right? So this is delta T1 minus delta T2 upon ln delta T1 delta T2. So I know delta T1, but I don't know delta T2. So what do? I need to find out fourth temperature. How will I find out fourth temperature? Our heat transfer equation m dot Cp or m dot H Cph TH inlet minus TH exit is equals to m dot C CPC TC exit minus TC inlet. Now I know all the temperatures. I just don't know this one. Okay. But one thing is different. What? I don't know mass flow rate. I know specific heat. This is given specific heat. But I don't know mass flow rate. How will I calculate mass flow rate? By mass flow rate is equals to what is density? Density is equals to mass per unit volume. And I can, if I put dot here, so this is also dot. So mass flow rate is equals to density into volume फ्लो रेट. ठीक है. तो what is mass flow rate? What is mass flow rate? It is 1000 kg per meter cube into 1 second. Mass flow rate of hot fluid. Okay, so density will remain same. Volume flow rate is kg per meter cube into 25 liters per second. And how do I convert liters into meter cube? I will multiply it by 10 to the power minus 3. Okay, meter cube per liters. Okay, chalo. Now you can find out what, by this and this will get cancelled because it is in divide, and meter cube will get cancelled, liter and liter will get cancelled. Ultimately you will get 25 kg per second. Okay, similarly for cold fluid you can do, but ultimately you will find 19 kg per second. Is it clear? Why I am writing directly 19 kg per second? Because you are going to multiply by the density and also you will convert liter into meter cube. ठीक है, चलो. So now you know everything. You can put in the, you can put here 19. No, 1 second. 25 into Cp of water. Okay, and hot fluid inlet is at 46. 46 minus hot fluid exit is equals to 19 into AB. It is also same, and exit is what? Exit 38 minus 10. 38 minus 10. Okay, so this and this will get cancelled. THE you will get. THE you will get. How much is THE? Okay, 24.72 degrees Celsius. Okay, now this is your 24.72. So now you can calculate delta T2 and delta T1 you can calculate. You can put it here and you will find out. This is what? It is delta T2 is equals to 14.73, no? And delta T1 is 8. Delta T1 is 8. So once you put this value, yes, once you put this value 14.72 minus 8 upon ln 14.72 by 8. So now I have actually written not delta. I have, look, this formula is delta T1 minus delta T2. But this is not that. This is what? This is delta T2 minus delta T1 upon ln delta T2 by delta T. So both are same. You can put it anyway. No problem in that. Okay. So because here if you can take 1 minus here, you can take 1 minus in the denominator. So it will come as same. Okay. So you have already calculated it. It is 11.02 degree Celsius. Very nice. Clear? Chalo. Next question. Alright, looks like a very big question, ना? चलो ठीक है. सबसे पहले पैरेलल फ्लो, वेरी इंपॉर्टेंट इंफॉर्मेशन. पैरेलल फ्लो हीट एक्सचेंजर operating under steady state. Okay, operating under steady state. The heat capacity rates are also given. Is it given or not? Achha, it is saying the heat capacity rates of hot and cold fluid are equal. Arey wow, very nice. It is saying by mcp of hot fluid is equals to mcp of cold fluid. So what type of heat exchanger is this? What type of, yes, C is equals to 1. Very nice. But what type of heat exchanger is this? It is anyone? Yes, it is balanced. It is called as balanced heat exchanger. If C is 0, then what will be happening? Can you tell me if C is 0, then what will be happening? Phase change. Very nice. Very nice. चलो ठीक है. Phase change. चलो. Hot fluid flowing at 1 kg and Cp is this. So hot fluid is given as m dot H is equals to 1 kg per second and Cp of H is 4 kilojoule per kg Kelvin. Okay. चलो. Enters the heat exchanger at count parallel flow है parallel flow. Let us draw parallel flow. So it is talking about hot fluid. So hot fluid is entering at 102 degrees Celsius, while the cold fluid is entering at 15 degrees Celsius. Overall heat transfer coefficient is also given 1 kilowatt per meter square Kelvin. Corresponding heat transfer area is also given. Area is also given 5 meter square. Neglect heat transfer between heat exchanger and the ambient. What does it mean? It means that the heat exchanger is completely insulated. Heat exchanger is completely insulated. Okay. Now effectiveness they are giving me, and look, that's why I was telling you, you do not expect to remember them. Maximum you need to remember the spatial conditions that I have talked about. And anyway, in this question, they have already given us the effectiveness in this particular case. And we have proved this as well. We have put the values and we have proved this as well anyway. But they have given in question, they have reduced our work. Okay. They are asking the exit temperature for cold fluid. I need to find out TC exit. I do not know even TC, TH exit. So what will be your approach? What will be your approach? Look, you need to find out effectiveness. You need to find out effectiveness. From effectiveness, you can find out your temperature, either THE or TC. How do you find out your effectiveness? You need NTU. NTU, what is the definition of NTU? Tell me very quickly. What is the definition of NTU? Yes, UA upon M dot CP minimum. How do you find out which one is minimum? Only one is given. Bhaiya, both are same. Both are same. Okay. So now, so NTU is equals to U is given 1 kilowatt, 1 kilowatt, and area I think was 5 meter square. Okay. And MCP is 4, right? 1 into 4. Yeah. Yeah. 1 into 4. And this is also in kilojoule. And this is also in kilowatt. So units are consistent. Okay. So it is 4. 1, 4. Okay. So it will be 5.4. It is 1.25. Now everything you know to calculate effectiveness. 1 minus e to the power minus 2 NTU upon 2. Okay, you know everything. 1 minus e to the power minus 2 into 1.25 by 2. How much is effectiveness? How much is effectiveness? Yes, 0.4589. Now, if you know 0.8549, so you know Q dot actual upon Q dot maximum. Now maximum, it does not matter whatever you want to write because both are same. Okay, both are same. But actual will vary based upon what do you need. You don't need hot temperature. Hot exit temperature you do not need. You need cold fluid exit temperature. So let me take cold fluid only. So what is cold fluid? TC exit minus TC inlet upon, because MCP will get cancelled. Okay. THI minus TCI. Very nice. But this is something that I do not know. 0.4589. I do not know this. I know TCI. TCI is 15. It is 15. And it is 102 minus 15. Only one unknown temperature. And you have calculated 55. Very nice. सिंपल क्वेश्चन ठीक है चलो Let us move on to the next question. Any doubt till now? 54.92 is also okay. 55. Any doubt till now? Chalo. This doubt, you know why this doubt is not there? Because I am expecting that you have revised it. Agar revise, if you wouldn't have revised, no, then you will be confused in all the formulas, all the special cases. But that is why I said please revise, so that you will get a second revision during your question practice. Okay, chalo. A balanced counterflow heat exchanger. Now there is two important information here. Balanced counterflow. Very nice. Okay, so counterflow is, let me draw counterflow. As soon as you are able to identify which type of heat exchanger it is, you need to draw this diagram. Okay, now MCP is same, surface area is same. Look, C is equals to 1. Very nice, Sean, very good. Area is equals to 20 meter square, and U is also given 20 watt per meter Kelvin. Now air entering at 0.4 kg per second and 280 Kelvin is to be preheated. So this air, this 280 Kelvin air is hot or cold? Is it hot or cold? It is cold. Very nice. Because it needs to be preheated. So it is entering at 280 Kelvin and preheated by the air leaving the system at 0.4 kg per second and 300. What is 300 Kelvin? What is 300 Kelvin? Can you tell me? Yes, is to be preheated. Air entering at 0.4 kg per second and 280 Kelvin is to be preheated by the air leaving the system at 0.4 and 300 Kelvin. The temperature of preheated air is, I need to find out this temperature, TC2. And you see this 300 Kelvin. This 300 Kelvin is what? TC. I do not, 1 second. Why are you thinking it is inlet? Because as per the statement is saying, I think it is exit. No. Air entering at 0.4. So this is 0.4, of course. And 280 Kelvin. Air is entering at this temperature. Is to be preheated by the air leaving the system at 0.4 kg per second and 300 Kelvin. Leaving, no, it is, isn't it leaving? So isn't it should be 300 Kelvin, this one? Don't you think? What do you think? By the air leaving at 0.4 kg per second, heat exchanger surface area this, and overall heat transfer coefficient at air entering at 0.4 kg per second. Yeah, I mean that makes sense actually, but I am not very sure what the question is saying. If system is a balanced counterflow heat exchanger surface area, this air entering at is to be preheated by the air leaving the system at, it could be, look, it could, this system could be your your flue gases or something. So it could be coming out from power plant or the boiler. So then it must be 300 Kelvin here if it is entering here. Otherwise 300 Kelvin is this. Otherwise 300 Kelvin is this. Okay, so how do you want to solve it? Look, I am not very sure what the question is saying. So it's not important what the question, basically we need to understand what the question is saying. That is very important. But this language is not very clear, so I cannot say 100%. Maybe if you check the solution somewhere, you can get some other solution. But how do you want to solve it? Tell me. We can solve it that way only. Do you want to take inlet or exit? We can see that what answer we are getting, and then we can verify and we can come back again. How do you want to solve it? Exit or inlet? You want to take it at inlet? Chalo, theek hai, we can take it as inlet. I was just thinking maybe we can take it as outlet and check what answer we are getting, and then we can take it as inlet and see what answer we are getting. Chalo, koi nahi, we can take it as inlet. Chalo. So this is 300 Kelvin. Now this is my delta T1, delta T2. This is my TC exit, TH exit, and this is my delta T1. Temperature of the preheated air they are asking. That means they are asking this. They are asking this. Okay, chalo. Now tell me what. How can I calculate TC2? See, TC2, how can I calculate? Look, I know only two temperatures. I do not know three temperatures. I do not know three temperatures. Otherwise, I can use my M dot H CPH THI minus THE is equals to M dot CCPC TCE minus TCI. Okay. If I know three temperatures, I can use this equation. Then what else I can do? Can you tell me? Any guesses? Any guesses? What can you do?
Hello, sir.
Yeah, 1 second. Yes, tell me.
So, sir, here what I did first. First is the balanced counter flow. So I know that
Yes,
delta
very
T1
nice.
is equals to delta T2.
Yes, very nice.
And
So,
I know that the Q net formula is QATM. So TM, if we try to find out, so we know the exit and entering temperature. So the TM is already, it's given as 20, 300 minus 280. So I can calculate Q is equals to UA TM. And
yes,
TM
yes,
is
yes.
nothing but, yes. And with the
Yes,
help
so
of that, I can
basically,
write,
yeah,
yes,
I
sir.
need to bring it to one unknown, right?
Yes,
So
sir.
that
And
is
then
actually
we can equate it to the,
you are
what I
saying
was
this is
saying.
Q and this is UA delta TM, and this is basically equal to delta T1 or delta T2, right? This is what you are
Exactly,
saying.
sir. And then we can equate it to CP,
Hmm.
TC exit minus TCI, with the
Got it,
help of
got
which
it,
we
got
can
it.
calculate temperature.
Yes, yes, yes. So because you need this, you need this. Okay, so let me take delta T1. है ना? If I need to calculate this, so I can take delta T2 here instead of this, right? So
Yes,
if
sir.
I take this, what can I write? I can write UA 300 minus 2C2. This I can write. And now let me take what? I can take this. I can take this, right? So this is no. I can take this. I should take this because TC is unknown, right? So M dot C CPC TCE minus TCI. Now only one unknown. What is the unknown here? What is the unknown here? TC exit. TC exit or TC2, whatever. Yes. Okay. And you know this is 20. Area is 20, 300 minus 2C2, and M is also given. M is 0.4. This is 100. TC exit I do not know. Inlet I know 280. So one equation, one unknown. Very nice. So I can calculate TC2. How much is TC2? How much is TC2?
Sir, here I have one query, sir.
Yeah, tell me.
Sir, here when we calculate the value of Tm, so if we are calculating delta T1 or delta
Hmm.
T2, so for
Hmm.
example, it will be the hot temperature inlet minus cool temperature exit.
Yes.
So, sir, here you have written that Q equals to 300 minus TC. 2 you
No,
have
delta
written.
T1 is delta T1 is what? This is delta T1. No, this and minus this. What is delta T1?
Because what I was thinking, so
Okay.
no,
What are tell me what are you thinking?
because in question they have given by air leaving,
No,
because
you want me to take as exit. Do you want to
exactly,
solve
sir,
it like
because the
that?
air leaving is, yes, sir, air leaving is 300 Kelvin. They have mentioned
So
it.
we can try that as well. I am not sure what the question is saying because it is very, I know, like sometimes it happens. You can't do anything about it. Sometimes even in any competitive exam, what actually happens is you will get a question that is confusing for all. So you really can't do anything about it. This is 280. This is 280, right?
Exactly, sir. Through this we can calculate.
Now,
Otherwise, we won't be
now
getting
you
the right
know
answer.
delta T2, which is equals to
Exactly.
20,
Yeah.
right? This is 20. Now, can you calculate Q dot is equals to U A delta Tm is equals to now. Now, what do I need? What do I need? You tell me. I need M dot Cp M dot H. Now I should take H, isn't it?
Yes, sir.
Cph. No, 1 second. Even if I take
The
the
it will
cold fluid, it is okay.
the
Even
cold
if
fluid
I
it will
take,
remain the same, sir, because both values are
yeah,
same.
yeah, it does not matter much.
Yes, sir.
M dot C CPC TC exit minus TC inlet, right? Now
Right,
only
sir.
one unknown is there here. This one. This is 20. This is 20. This is 20. Is equals to this is known. How much is this? 0.4 into 100. 0.4 into 1000. Sorry, not 100. And only TCE is unknown, and this is 280. Now tell me how much you are getting TC exit.
So 300 will get.
You will get 300.
Yes, sir.
Okay, of course you can get 300. No problem with that. Because what is the limiting condition? Do you know what is the limiting condition for counterflow? The limiting condition is you cannot get more than, if this is your THI and this is your TCE, so your TCE cannot be greater than THI, right?
Yes,
And of
sir.
course, THI will be more than 300. So it is also a valid answer. It is also a valid answer. 300. Okay. And by this answer, how much you are getting this one? How much are you getting from this answer? This solution 290. Okay, you are getting 290. So yeah, both options are available here. So we can't even guess what can we do here. You know, what you need to do is you try to see this in several previous year questions. Like for example, I don't know if you have any book of previous year papers. Try to see how they have solved it and what explanation they have given, because how the way that we are reading the question, it is not very clear that if this is the exit temperature or inlet temperature, because both the conditions it's satisfying. Even if TC2 is 290, it is a valid answer. It is, you cannot invalidate this answer. You can only invalidate that this answer if TC2 goes, if you are taking 300 at this, right? For example, if you have taken TH inlet is equals to 300 and you are getting TC2 greater than 300, that means the solution that we have done is wrong. Isn't it? Do you understand this point or not? Okay, so this is the only way of validating our answer. But by using both the ways, we are, like the answer is okay, the answer is not like it is not invalid in any sense. So what you can do is you can maybe go to other different books. You can check this question on internet as well and see what type of solution they have done it, and then maybe try to understand the logic. I will also try to do that, because by just reading, or maybe I don't know, I left a word or something in this question, I'm not very sure. You know, so also I'll take a look, also you take a look. Otherwise I think we are clear on the concept, isn't it? Are we clear on the concept? Because that is more important. Because these type of things are very rare. कि you are not able to understand what is happening. चलो ठीक है. Sahil, is this okay? So we have done both ways, but of course we are getting different answer, and both answers are, I mean, valid. You cannot invalidate any answer. चलो next question. What the next question is saying? It is saying, consider a parallel flow heat exchanger with area AP and a counter flow heat exchanger with area AC. Okay. In both the heat exchanger, the hot steam flowing at 1 second. Let me take a parallel flow. Let me take a counter flow. Okay. Parallel flow will be like this. Counter flow will be like this. Chalo. Now what the question is saying. Parallel flow area is AP. Counter flow area is AC. In both the heat exchanger, hot steam is flowing. If this is your m dot h, it is 1 kg per. Let me write it in between so that I don't have to write it again and again. So in both hot steam flowing in both heat exchanger, m dot h is equals to 1 kg per second, and it is from 80 to 50. It is also from 80 to 50. For the cold steam in both the heat exchangers, the flow rate and the inlet temperature are 2 kg. So for both of them, cold fluid is 2 kg per second and inlet temperature is 10 degrees. So iska inlet is this, iska inlet is this. Okay? Is it clear? The hot and cold steams in both the heat exchangers are of same fluid. If they are same fluid, means Cp is also same. Okay. And both, look, first of all, hot and cold steam, they are the same fluid. And in parallel and counter flow, that means Cp is same for all the cases, for all hot and cold fluid and for parallel and counter flow. Now, both heat exchangers have the same overall heat transfer coefficient. U is also same. Now the ratio AC by AP, AC by AP, I need to find out. Okay, AC by AP, I need to find out. How do I do that? Look, chalo. I can say that I need to find out area of counter flow upon area of parallel flow. This I need to find out. I know area term, where the area terms come. Q dot is equals to UA delta TM. So if I say Q dot counter flow upon Q dot parallel flow is equals to U A counter flow delta TM counter flow is equals to U A parallel flow delta TM parallel flow, then U and U can get cancelled. U and U can get cancelled. Okay. Now, so I need to find out delta Tm and delta Tm. Then I will be able to find out what is the area. Okay, is it clear? So I need to find out delta Tm. For delta Tm, I need to find out this temperature. It's very simple, right? It's very simple. Look, by I can find out mCp of hot fluid and 80 minus 50 is equals to mCp of cold fluid is equals to Tc exit minus 10. This and this will get cancelled. This is 30 is equals to Tce minus 10. Tce is equals to 40 degrees Celsius. So this is 40. Now this is delta T2 is equals to 10. and delta T1 is equals to 70. ठीक है. Same thing we can do here. Same thing we can do here. Can you do that? Can you tell me what is this TC exit? TC exit, look, 80 minus 50 is equals to TC exit minus 10. This is again 30 plus 10 is equals to TCE. TCE. Okay. So this is also 40. So now this is delta T1 is 40 and delta T2 is 40. One second. Cold steam in both the heat exchanger, flow rate, inlet and are 2 kg and 10 degrees Celsius. Slightly wrong. It's slightly wrong. Okay. How is it wrong? I have cold fluid is 2. Cold fluid is 2. It is not same. Okay. So m dot h CPH 80 minus 50 is equals to m dot c CPC this I need to find out. TC exit minus 10. Now this is 1. Look, this is 1. CP and CP will get cancelled. Into 30 is equals to this is 2 and this is TCE minus 10. TCE minus 10. Okay. So how much is TCE? How much is TCE? 25. Very nice. So now this is 25. 25. I'm really sorry for I took it lightly. Okay. Now so delta T2 is 25. Delta T2 is 25. Okay, very nice. Same thing we can do for counterflow. Same thing we can do. Can you tell me what is TCE for counterflow? What is TCE for counterflow? TCE for counterflow is also 25 degrees Celsius. Okay. Now tell me what is this? How much this? This is 55 degrees Celsius delta T1. Now can you calculate delta Tm of counterflow of, let's say, parallel flow? How much is it? 70 minus 25. Do I need to write formulas or I can write directly? And delta Tm of counterflow is equals to 55. I think it was 55 minus 40. ठीक है. Yes. So I don't. How much is delta T parallel? Delta T parallel, delta T counter. Yes, Sahil, that is, I think, correct. That is correct. How much delta Tm parallel and counter? Can you tell me? Okay, how have you solved it then? by using NTU. What have you done? Tell me.
Hello, sir.
Yeah, tell me, tell me.
So, sir, first I have calculated the value of E, and the value of E
Okay.
will be given by THI minus THI minus TH exit upon THI minus TCI. So I will get the value of E is 3 by 7. Now we know the formula uh, that for the parallel flow, the
Hmm.
formula of the effectiveness is 1 minus exponential bracket minus NTU 1 plus R divided by 1 plus
Okay, so
R.
you have
Uh,
calculated NTU is equals to UA upon MCP minimum, huh?
Yes, sir. Yes, sir. Yes, sir.
Okay, for both the heat
Yes,
exchangers.
sir. For both the heat
Okay.
exchanger, I found out, and since they have given U is same, so it will get cancelled out, and C is equals to 1, and
Hmm.
by which I'll get the value of area, the ratio of
Yes,
areas
yes,
I'll get
yes.
it.
Correct, correct, correct. चलो ठीक है तो we have also calculated this delta T. I think Sean is saying 47. This is 47.103 and this is 43.71. So simply we can put this delta C upon delta C upon AP is equals to delta TM parallel upon delta TM counter. Okay, 1 second. Parallel should be less than this, right? This is what are the values? Yes, counter will be higher. That's what. Always remember 43 point कितना था 43.71 and this is 47.103. Always remember that delta Tm of counter is greater than delta T of M of parallel. This I have told you earlier as well, and this is the proof of it as well. Okay, under the same conditions, delta Tm counter is always greater than delta Tm parallel. Okay, if you are getting it in the opposite way, that means you have done something wrong. So now this is 43.71 upon 47.103 and the answer is 0.928. Chalo, ठीक है 928 Sean has calculated. Very nice. So this is 0.928. ठीक है? Is it clear? चलो. Let us move on to the next question. This is very simple. Tell me the answer. The maximum possible heat transfer between the two fluids is maximum possible heat transfer between the two fluids is A, B, C, D. Which one is the right answer? Yes, B is the right answer. That is GATE 2016 1 mark question. Chalo, next. 2017 2 mark question. What does the question says? In a counter flow heat exchanger, water is heated. चलो जल्दी जल्दी करेंगे सर कितना टाइम हो गया चलो अभी तो है टाइम व्हाट इज ओके 10:30 जल्दी जल्दी करते हैं सर काउंटर फ्लो है काउंटर फ्लो ड्रॉ कर लो वी हैव काउंटर फ्लो लेट्स ड्रॉ काउंटर फ्लो ओके water is heated that means water is the cold fluid so m dot c is equals to 1.5 kg per second from 40 to 80 degrees celsius by an oil entering at so oil is coming at 120 coming out at 60 specific heat of water that is cp of water is 4.2 and cp of oil is 2 kilojoule per kg Kelvin. Okay. Overall heat transfer coefficient is also given. Required heat transfer surface area I need to find out. Required heat transfer surface area. Of course, if I need to find out heat transfer area, I would use UA delta Tm. UA delta Tm. Okay. Now, how do we calculate delta Tm? Very simple. Delta all the temperatures are given. Very simple. By this is your delta T1 is how much? 40 and this is 20. So delta Tm is equals to 40 minus 20 upon ln 40 by 20. This is 20 upon ln 2. कितना है ln ये? Delta Tm कितना है? How much is delta Tm? 28. Very nice. 28.845. Okay. Now you can find out Q as well. How can you find out Q? By all the values of cold fluid is given to you. So I can write 1.5 into 4.2 into 80 by 40 is equals to U is also given 400. Area I need to find out, and this is 28.854. So area you have calculated as how much? Yes, D is correct. 21.84 meter square. Yes, D is the right answer. Okay, let's move on. Chalo. Saturated steam at 100 degrees Celsius condenses on the outside of a tube. Condenses on the outside of the tube. Cold fluid enters the tube at 20 degrees Celsius and exit at this. The value of LMTD is how much? I have no idea it is counter flow or parallel flow. So what should I do? What should I do? There is nothing, no information about parallel or counter flow. Yes, C is 0. Of course, C is 0. Then C is 0, yes. But what about LMTD? Anyone? Yes. Because whenever there is a phase change happening, by steam is condensing means the temperature is same. This will remain at 100 degrees Celsius. This is also 100 degrees Celsius. Now cold fluid ka temperature we know. Now let us assume as parallel flow. Parallel flow let us assume. Okay, it does not matter what you are assuming, your answer will come same. 50 degrees Celsius. Okay, LMTD निकाल लो. This is 80. This is 50. So delta Tm is equals to 80 minus 50 upon ln 80 by 50. 30 is what? What is 30? Just calculate it one more time because 80 minus 50 is 30 divided by ln 80 by 50. Answer is yeah. You took HC same. What is HC? Yes, that is correct. Sahil, Shruti, what calculation mistake you have done now? Okay, heat capacity. No information, yeah. Why? And heat capacity cannot be same, yeah. One fluid temperature is constant. Its specific is heat capacity is infinite. This has a finite heat capacity. It cannot be same. Okay. Now, if you want to calculate for counter flow, then you can do that as well. Counter flow will be like this, right? So this is 30. No, this is mess. If you want to do it for counter flow, you can do it for counter flow as well. For example, this is 100. This is 100. Counter flow will be like this. 1 second. Yeah. This is 30. This is 50. Okay. This is 20. I'm sorry, not 30. This is 20. So now this is 80 and this is 50. again, if you solve, you will get the same answer. Again, if you solve, yeah, we will get the same. Very nice. So it does not matter. As soon as you say phase change, as soon as you say the word condenses or evaporated, evaporated means phase will be changing of hot fluid or cold fluid. Evaporation. In evaporation, phase will change of hot fluid or cold fluid. Yes. And in evaporation, it is cold fluid. But always remember, if phase change is happening, either condensation or evaporation, delta T parallel is equals to delta T counter. So it does not matter what type of heat exchanger you have. It does not matter. You can directly calculate it. ठीक है? चलो. Next question. Okay. Steam in a condenser of a thermal power plant is to be condensed. Steam in a condenser of thermal power plant is to be condensed at a temperature of this with cooling water which enters the tube of a condenser at this and exit at 22. Total surface area is given, overall heat transfer coefficient is given. Heat transfer आपको निकालना है of the condenser. So heat transfer of heat exchanger is equals to UA delta Tm. Delta Tm. Now U is given, area is given, delta Tm I need to calculate. It does not matter you take parallel or counter because again condensing is happening. Again steam is condensed into water at 30 degrees Celsius. Okay, with a cooling water which enters the tube of condenser at let me take parallel flow. I can take counter as well, does not matter, but ठीक है कुछ भी ले लो. And coming out at 22. So delta Tm is what? This is 16 and this is 8. So delta Tm is equals to 16 minus 8 upon ln 16 by 8. So delta Tm is equals to 8 by ln 2. And delta Tm, how much is delta Tm? Can you tell me? 11.54. Okay, 11.54 degrees Celsius. You substitute this here. So Q dot heat exchanger, U is how much? U is how much? And it is 2000. Area is 50. And this is 11.54. You can calculate. So you will get in watts. The answer you will get in watts. But when you convert it into megawatts, it is what Sahil and Sean has given, megawatt. It's not small m, Sean, not small l. You should know the difference between small m and capital M. Small m means 10 to power minus 3 milli. But sometimes this typing error could make a lot of differences. Okay, chalo. ठीक है? Is it clear? Let's move on to the next question. Chalo. I think this is we have 2-3 more questions. Okay, wait. Chalo. Hot and cold fluid enters a parallel flow double tube heat exchanger at. So now entering they have told us, and parallel flow they have told us. So bhaiya parallel flow, as I know, it is like this, and both are entering at 100 and 15, entering at this. Heat capacity is also given CH. CH means what? CH means what? M dot Cp. 2000 watt per Kelvin, and Cc is 1200 watt per Kelvin. Yes. Outlet temperature of cold fluid is given 45 LMTD. I need to find out. Do I have any problem with this question? Do I have, like, now I think everything is written in my mind, right? सबसे पहले you do MCPH 100 minus TH exit is equals to MCP cold 45 minus 15. Okay, this is 2000. 100 minus THE 1200. 15, this is 30. TH you can calculate. TH you can calculate. TH will be how much? How much is delta HE? Why, let us divide it by 2000. Yes, it is 82. Very nice. So if it is 82, how much is delta T2? Delta T2 is how much? 40, 75, 85. 45. 37, yes. Okay. So calculate delta Tm. 85 minus 37 upon ln 85 by 37, and answer you have already calculated 71, or yes, 71. Very nice. Degree Celsius, but they are asking in Kelvin. So what will be the answer? Can you calculate that in Kelvin? Can you convert this into Kelvin? Really? Really? You have actually converted into Kelvin, huh? Beta, this is temperature difference. Look, tell me one thing. What is this? This is temperature difference, and this is unitless. There is no unit. So it is temperature difference only. No, it will remain same. That is how you will be tricked. Yes. Look, the numerator is temperature difference. So it does not matter if it is degree Celsius and denominator is dimensionless, isn't it? Clear? Chalo, let us move on. Okay, next question. Concentric tube counter flow. Very important information is this only. Okay, every time, as soon as you are able to remember, see what type of heat exchanger, draw this diagram. Like this, like this. Hot oil means hot fluid. 10265. Cold fluid is entering at 25, 42. Ab jaldi se tell me what is delta Tm. Very quickly tell me. Shruti, what are you doing? Why 2.88? What is 2.88? 60 minus 40 ln 60 by 40. Yes, 49.326. What did you do? Yes, 49.33. Okay, so see, it is GATE 2020 question. It is a very recent question. Okay, you forgot zeros. चलो ठीक है. It is a very recent question. You see, it GATE 2020 question. Or just take out previous year GATE questions and try to solve them yourself. I have actually solved many, but you try to solve them yourself, and once they are done, you start moving on to other questions, workbook questions, practice questions. How many? solve as many questions as possible. But all these are great questions, and I think you are very comfortable in this, isn't it? Are you not comfortable in this? By the concept that we have covered, do you have any doubt? Do you have any kisa? No, this is not something that we have covered, because I have covered concept in a way that everything is already clear. Clear. ठीक है? चलो. I think this is the last question. Yes. चलो. A shell and tube heat exchanger is used as a steam condenser. So as soon as you see phase change, you do not worry about it is counterflow or parallel flow. It does not matter. Otherwise, you will keep looking words for counterflow, parallel flow. Sometimes you may get the word counter or parallel flow, but mostly you do not see that word. So that just leave that. You do not want to know, even know. It does not matter. Okay. Now coolant water enters. Now let me draw a parallel flow. But you just be aware of it if it is a condenser or if it is an evaporator, because if it is evaporator, the horizontal line will be drawn below the hot fluid. Okay, it is very important information. Okay. Now coolant water enters at 300 Kelvin at a rate of kg per second. Overall heat transfer coefficient is given this, and total heat transfer area is also given. Steam condenses at a constant temperature of 350 Kelvin. Assume that the specific heat of coolant water is, so this is C is equals to 4000 joule per kg Kelvin. The temperature of coolant water coming out, so this is 350 itself. Okay, so I need to find out TC2. TC2 I need to find out. So can you, what can you do here? What can you do here? Any idea? Any suggestions? Look, you cannot use the equation. One thing is for sure, that you cannot use the equation m dot h cph th exit minus th inlet. Okay, because there is no temperature difference. You cannot use this equation. Then what else you can do? What else you can do? You cannot calculate LMTD. Any idea?
Hello, sir.
Yes, yes, yes. Tell me, tell me.
So here we can apply one thing, sir. Like
Yes,
first we can what we can do. First we can we know that Q is equals to U A delta T. Sorry, sir, NTU. We can use the formula of NTU. U is given, A is given. And for C, the
yes,
specific heat they have given 4000 and 100 is the mass flow rate. So we'll get the NTU value.
yes, yes. And you know it is
And that
already
we
minimum.
can,
You know this
yes,
is
sir, yes,
already
sir.
minimum because this one is infinite. Because of course it is minimum. ठीक है? चलो फिर
And so we
बताओ
can use
then.
the formula of the effectiveness of the counter flow.
Effectiveness of counter flow, but it is parallel flow.
Sorry, sir. Yeah, when there is a phase change. Yes, 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 yes. So, sir, we can use the parallel flow. In that case, we'll get the value of effect.
Both are
Both we can
same
use actually.
actually.
Yes, both are same. EP is equals to. So anyone we can use and we can find out the value of effectiveness.
Yes. Then
And so the effectiveness we can know the formula, that is THI minus THO divided by delta T max.
yes. Very nice. Very nice. चलो तो if you know already, then start solving it. Sean, Shruti,
Yes, sir.
tell me what is TC2. I am not solving it. I'm just writing it. You can take m dot c cpc tc2 minus tc1 upon m dot cp minimum thi minus tci. This and this will get cancelled. Chalo. Solve it very quickly and tell me what is the answer of TC2. Are you solving it? $338.84. Very nice. So your TC2 will come as 338.8 degrees Celsius or Kelvin? Kelvin. Yes, very nice, Kelvin. Because all the temperature are already given in Kelvin, so the answer will also be in Kelvin. Okay. Shruti, is it clear? Are you able to solve it? Yes, 338.8. So it is 339 also you can say, but it's fine. Okay, round off to nearest integer they are saying 339 is the answer. Okay. 339 is the answer. ठीक है चलो बहुत बढ़िया. So I hope you are comfortable in heat exchanger, or do you think you have missed something, or because I hope that in these 2 days we have covered everything. And I think, look, I am also a human being. I can say that I may leave 1% something that I may have, like mistakenly, like left out. Otherwise, I think I have covered 99.99% of the gate relevant syllabus. Okay, now what you can do is, how do you practice questions? Now, I would not recommend you solve gate questions, seriously. Okay, I would not recommend you solve gate questions. You start solving workbook, or if you are attempting any subject test series. Okay, because now we have covered almost our heat transfer. Okay, so if you have already done some test series, if there are heat exchanger questions or conduction questions, it is not just heat exchanger. I am talking about every topic. Okay, workbook, test series. I would not recommend books, because books questions are very lengthy, and like for example, in the same question they will ask you 3-4 concept, and most of the things will not be even relevant for gate. Okay, so that is why I would not recommend, but still if you have time, then try to go for book questions as well. I mean, I don't strongly recommend, but try to do that if you want. Okay, Sanjal, I think you can take, but again, Sanjal is conceptually good, not numerical wise good. Okay, so you can, or workbook, test series, or any practice questions that you can get. But the point is, practice as many questions as possible. Okay. So now, just very friendly, I want to ask you, we are about to reach the end of heat and mass transfer. Only two main topics are remaining. What are two main topics? Can you tell me what are the topics remaining? What are the two main? Yes. So radiation. This is what we are going to start tomorrow. We will finish this in two class, 1 and 2, and then convection. We will cover it in first, second, and I would say 2.5, because the last class only will solve questions, because the thing is there are so many concepts in this and so many things to cover. Look, convection I don't like much. Look, I actually like convection, at a point earlier I was actually an expert in convection, but I don't like convection from gate perspective because there are so many concepts, so many things. There is continuity equation, momentum conservation equation, energy balance, energy conservation equation, and the solution of them, then boundary layer conditions. So many things are there. But if you talk about gate perspective, then very few questions and very formula based questions are asked in gate. Okay, so there is no point in covering them. There is only momentum equation can take hours to solve. If you just, and then if we talk about boundary conditions, hydrodynamic boundary layer, thermal boundary layer, so it is a very complicated topic, which is a research based topic. It is a research based topic. Most of the research in heat transfer happens on convection, but from gate perspective it is not, like the amount of work that we put is not justified for it. So anyway, but still I need around 2.5 classes for it. Okay, so let's say we will, I am not going to do any derivations. I am going to simplify that everything, and I am going to give you on a platter. Like, I will give you as it is, because it is not possible to solve all the derivations in 3 classes. Okay, so I'll give you as it is, and you have to remember the equations that we are going to use. Okay, that is for your benefit only and my benefit, of course. ठीक है, चलो. So we will start radiation tomorrow, and in two. So now around 5 classes are still remaining. Five, at least 4 and 4.5, I would say, because last day I will not. I am assuming I will not take the whole class. Maybe 1 hour, 1.5 hour, something I'll take. ठीक है. So we are almost at the end, and of course we have covered the major portion in heat and mass transfer. This is also important. Radiation is also important. ठीक है. Now, could you please tell me a friendly, a very fair, a very justified, no biased opinion of your heat and mass transfer till now? कि how many ratings would you say out of 10? कि are you, not about how I am teaching, it's about how you are understanding. कि you have to rate your understanding. कि out of 10, how much do you rate you understand HMT? Can you do that for me? Oh, very nice, Sean. Thank you so much. 9 is actually very nice. Nice. Shruti, Sahil, I'm waiting for you. Could you just give me very quickly, what do you think? Just, I mean, it does not matter much. I am not going to change my style of teaching anyway, but it gives me an understanding of how, how comfortable you are with the subject, or do I need to add or subtract few things? Okay, very nice, very nice. Thank you. In convection, again, I'll give you some notes that I'll summarize. Ki bhai only these things need, because we will do so many things there, but 90% are useless actually. I would say, let's say 80% are useless. Only 20% is useful. Chalo, theek hai. Anyway, I would say it's really good, sir. Achha, you have no rating. Chalo, theek hai. I'm happy with that. If you are happy, chalo. Chalo, I hope that you have enjoyed HMT, and maybe next time I'll take your thermodynamics as well. And thermodynamics, I think you will have fun, because I like that subject. I love that subject. Okay, so, and I really have good comments about thermodynamics wherever I have taught it. So I hope you will enjoy it, but I don't think you will be here anyway. Chalo, theek hai. चलो फिर, I think this is the end of the class, sir. I don't want to rate, cause right now whatever we have discussed, I'm able to solve most of the problems. Okay, ठीक है, it's okay. Summary notes here as such, I don't. What I usually do I do a summary after class. If, for example, there are like, entropy is a very confusing topic. Okay, so in entropy, I summarized. Okay, I'll do one thing. I'll send you last PPT where I have summarized those. Okay, I'll do that. Okay, I'll do that, and uh, because I don't have any notes as such, but in PPT I have summarized most of the things. for entropy and for work transfer as well, work and heat transfer, that will also I give you. Okay, I'll share the picture in the thermal group, thermal fluid group. Okay, chalo, chalo. I hope. Okay, chalo, chalo. Very nice. So I'll see you tomorrow at 1 and we will start radiation. ठीक है, चलिए. Thank you so much. Thank you, Sahil.